Okay, so before we really get into packet 2, which is all about, if you look here, computing derivatives, I want to look and fill in a little bit more on our cheat sheet here. So I want you to look in the derivatives column. This is kind of on the front, the side that we've been working on. And let's look at average rate of change, AROC. Remember, average rate of change is what you've been doing for years, since junior high. It's just basic slope. It's the slope. Do y'all remember which type of line? Okay, so I'm going to give you two options, tangent and secant. Secant. I mean, it was 50-50, right? All right, and so this was like where we maybe did f of b minus f of a over b minus a. It's basically slope, though. It's change in y over change in x. In a word problem, this could be change in pounds of flower petals over change in time. That's slope. Well, now you do. Okay, instantaneous rate of change. This was the new stuff, IROC. So this is slope of which other type of line? Tangent. All right, which is just occurring, it's just touching the graph at 1 point. That's the difference. Secant was 2 points, tangent was 1 point. And how do we find IROC? Derivative. Now this could be f prime of x, or it could be that you need to evaluate the derivative at a specific number. It depends upon how the directions are stated. If they say find the rate of change at x equals 2, then what they're asking you for is the derivative at that point, not just the derivative. All right, let's go over some of these derivative rules. Okay, so I like starting off with chain rule because chain rule really affects a lot of the rest of these. And this was the M&M, by the way. This is when we did the shell and the chocolate, and then we did peanut M&Ms. So chain rule is where you derived the outside, you left the inside the same, and then you went times the derivative of the inside. And so we're going to say u prime is the derivative of the inside. And I'm not doing u substitution. That's for integrating. I am using u here to represent a function, but it's not the same as u sub. Okay, what about product rule? So in this case, yeah. So we got it. You got it. So derivative, I've always been doing derivative of the first thing. That's where we start. Times just regular v plus for product rule, and then u times v prime. Notice that I only take derivative once, and they're not back to back. Okay, if you can remember that, you can get product rule even if you get the order mixed up a little bit. It's okay. Okay, how is quotient rule different than product rule?
Negative and it's over. And then you put it over. That came out. Squared.
It's okay. All right, and I'm going to put v in parentheses squared there, just so it's clear that, because a lot of times v is more than just one item, and if you don't put parentheses before the squared, it's going to affect your answer. Okay. What about derivative of x to a power? What happens to that power? Goes to the front, and then do we add one or subtract one from the power? Subtract when we derive. When do we add one? Antiderivatives or integration. Good. What about derivative of sine u? Cosine u, and then apply chain rule, u prime. Okay, what about cosine u? Negative sine u times u prime. Remember snow cone, snow cone? I give you a snow cone, but then I'm a mean bully, so I take it away. When you derive, you go down. When you integrate, you go up. That can help you with the whole minuses, minus plus thing. All right, what about derivative of tangent u? Secant squared u times u prime. And then notice tangent and then cotangent would just be negative cosecant squared u times u prime. If you never memorize these, now's your time. If you already memorized them, then this should be easy for you. All right, what about the derivative of secant u? Secant u, tan u in either order times u prime. And then again, from secant to cosecant, you just put a negative and then it's co everything. What most people forget here is if this u is something other than x, you've got to go times the derivative of that at the end. That's where most people mess up. All right, what about natural log of u? 1 over u times, big surprise here, u prime. Could I put that u prime on the top?
Yes.
Of course. E is for easy, so what's the derivative of e to the u? E to the u times e prime. And we saw that on the one we went over a little bit ago. Okay, this sine, how do you say that, by the way? Inverse sine or arc sine. Those two things mean the same thing. Okay, so this was more recent. This was like the end of chapter 5 stuff. All right. Although we learned it at the beginning of like in December, but then we really got into this. So I'm going to kind of give you a head start on this formula. 1 over, since it's sine, we're going to go square root. And then I'm going to do 1 minus. I'm just giving it to you, I guess. All right, 1 over square root for sine, 1 subtract u squared times u prime. And you could definitely put the u prime on the top of that. That would be fine. Okay, what about arctan? How is that one different?
There's 1 over something, both squared. Yeah.
Yeah. Okay, by the way, right here, just go ahead and cross off and a is a constant. That was just left over from, I used to have some other stuff at the bottom of this. There is one more formula that I didn't put on here, and it has to do with inverse, like when you're just regular inverse, and so we're gonna go over that next time. Okay, so that's why there's a blank there, and there's a blank because it's quite possible it might not even be on your test. It doesn't even make it to the test every year, so it's not a huge topic, but there'll be room for it. Okay, so let's start with number 1. All right, and again, I know this is hard to read, but you have your packet right in front of you, so you should not be looking, just look up there to see what I wrote, but we're gonna start with number 1. All right, are we gonna plug in the 0 first or derive first? You gotta derive first. Ooh, that's too fat. Hold on, I need to do some stuff here. There we go. Okay, we need to derive first. F prime of x equals the power is 2/3. So let's pull that 2/3 in the front. Keep the inside the same. We're going to get to derive the inside, but for now, it stays the same. What's the new power, though? Negative 1/3. We subtracted 1. And we got to go times now the derivative of the inside. Now, if you just write this, what's wrong with this?
You need to put the times 2 in parentheses.
Yeah, you need parentheses here because it looks like I'm just multiplying by the 2x and if I don't put those parentheses, and that might throw you off. Okay, let's do f prime of 0 now. Nice thing about 0 is it just gets rid of all the x's. So I'm not even going to write 0 squared or anything. I'm just going to write -1. Same thing here. I'm just going to write -2 because plugging 0 in for x, that's what that would do. And if you look at your answer choices, I do need to simplify. Okay? It's not too bad though because 1 and -1 are the easiest things to take to powers, even weird powers. Is this going to still be -1? Or is it going to turn into positive? Is there an even power? That's what you're looking for here. An even power like 2, 4, 6. That's what would change this to positive. That's not happening, so we're going to get a -1. And you really don't even need to go any more detailed than that. All right, so what do these numbers multiply out to be? Yeah, positive 4/3. We have two negatives. 2 times 2 is 4. So the answer is A. All right. Turn to number 11. And I'll try to find it on my little packet here. Here we go. Okay. All right, I will tell you, I'm going to work this problem 2 different ways. So you may just want to kind of watch, and then I'll give you some time to write down what you need to write down. All right, so if we're finding dy over dx, remember that's the same thing as y prime. All right, so if you have an equation like this, sine x equals e to the y, and you're trying to derive with respect to x, this is what we call implicit differentiation. I'm going to show you how to get out of that in a minute. I'm going to do it a different way, but let's go ahead and go with this for now. Derivative of sine x, that would be cosine x. What's the derivative of e to the y? E to the y. Remember, when you take derivative of a y, you got to go times dy over dx. We're going to look at another one of those in a minute. Really, I just need to get dy over dx by itself, right? So I just need to divide by e to the y. And the problem is, that's not an answer choice. The reason it's not is because it says in terms of x, and e to the y is not in terms of x. Okay, but if you're clever, which you may or may not be at the time when you take this problem, okay? I'm just saying, by clever, I'm almost kind of saying lucky. It's not all luck, but you may or may not see this. Do we know what e to the y is? Look at the beginning of the problem. What is e to the y the same as? It's the exact same thing as sine x. If you see that, then you can figure out the rest, because what is cosine x divided by sine x? Cotangent. This is why we're working this one. This is a tough one, I think. It's weird.
So if you don't figure that out.
If you don't see it, then you got to go, maybe I'll skip this one for now and come back to it, or maybe I'll work it a different way. So thinking back to the original problem, let me rewrite it over here, just so we can all look at it really big. Is there a way to get y by itself? You would take natural log of both sides, and we would get natural log of sine x, and natural log of e to the y would just be y. And so now this is a formula that's, I can just do like y prime. I'm going to switch sides here. All right, and how do we take derivative of natural log of sine x? Here we go, 1 over sine x times cosine, which is this, you get the same thing. Cosine over sine, that's cotangent. Both of these require going, okay, this is different. I need to figure something out here. Okay, and if you're like, that's not my strong suit, then this might be one you want to skip and come back to at the end. Maybe seeing it as something in another problem reminds you of something. Okay? All right. I want you now to turn, sorry, I can't. I want you to turn to 24. I'm going to have a fun time finding this one. Yeah, here we go. Whoops. So 24 is a free response. Remember, these are worth 9 points. There's usually 4 parts. And so, but for this packet, only parts A and B really pertain to what we're doing, okay? So we have this formula up here, okay? And we got to find y prime, which, again, that's the same thing as dy over dx. Okay, so I'm going to rewrite. I'm going to basically take derivative with respect to x of both sides. And I cannot read that, so I'm going to go off memory. Y'all tell me if I'm wrong here. Is this what it says on your paper? Okay. And so we cannot get y by itself here. So we have to do this one with implicit. That's why I wanted to work this one. And it was a free response, and there's going to be a tangent line. Okay, so you just take derivative of each piece. So derivative of x to the fourth, 4x cubed. Plain and simple when it's just an x. Now when you got to take derivative of this part, there's like a times there, and you got to use product rule. Okay, I'm going to write this up here for your benefit. These are your two pieces. I'm kind of spacing them apart. So with product rule, remember you got to take derivative of the first piece times the second piece plus the first piece times derivative of the second piece. And when you take derivative of y squared, you get 2y times, do you remember? dy over dx. Okay, and now we're going to do derivative of 4y to the fourth. 16, 4 times 4 is 16, y cubed. And again, that's a y term, so dy over dx, derivative of 0 is 0. All right, this is where we got to isolate dy over dx. So I'm going to take the two big terms that have that, and I'm going to leave those on the left, and then the other pieces I'm moving to the right. I'm going to go ahead and do here -5 times 2. You don't have to do that, but I am. And then I'm going to subtract over the 4x cubed, and I'm going to add over the 10xy squared. This is free response. So your answer and your work, that's what you're getting points on. So make sure you're showing your work. Okay, do you remember how we get just a single dy over dx? Give me a word here. Factor, group would, yeah, all of that's good. So we factor out dy over dx. We're left with -10x squared y plus 16y cubed. And then the right side's going to stay just how it is. Do you all have a question? I just multiplied this -5 times this 2. You do not have to do that. Okay, the last step I think is the most obvious one. That's the divide. You just get dy over dx by itself. Okay, please make sure you're showing your work here. If you're not sure if you should show a step, just show it, because it would really be a shame for you not to get all the points for something you understand because you didn't show your work. Like I said, you get a whole half of a page just for each part, so you'll have plenty of room on the actual AP test. All right, part B. Write an equation for line L. What do you need to write an equation of a line? You need a point. Hopefully they give you part of that point, and you need a slope. Okay, so if I look back up here, it says the L is the tangent line to the graph of f at x equals 2. So they're telling us the x value. Do they also tell us the y value? Read the rest of the question stem.
It's 1.
Yeah, right here. They're giving it to you. Let's say they didn't give it to you. How would you find that y value? You'd have to plug 2 in for x into the original expression and then do algebra to figure out y, which could be difficult or it might be easy. It just depends upon the problem. Okay, slope. We're going to use our derivative here. So I'm going to go -4 times 2 cubed. Make sure that you get all your squareds and your cubes and negatives and all that. I'm just plugging 2 in for x, and I'm plugging 1 in for y. Make sure you don't forget to actually write the equation of the line. You don't have to simplify the slope, by the way, though. This is fine to leave it just like that. Okay, it does end up being 3, I believe, if you do simplify it. But I'm going to show you, you can get full credit for writing what I'm writing. Yeah, so see what I almost were to put a plus there. So make sure that all your pluses and your times and all that is really clear. Also notice that since I didn't simplify, I put it in a big parentheses just to show that it was, you know, one thing and that that whole part needs to be multiplied to x minus 2. Like I said, this does simplify to 3, so you could have simplified it and written 3 there. But like, let's say you thought the slope was -3. You're going to lose points, or a point, or whatever it is on that problem. If number crunching is not your strength, you know, you need to know not to do that.